we need to obtain the derivative of y with respect to x whenever x and y are given in its parametric form. That means they have a theta dependence. So let's begin. We'll start with our function x, which is given by 3 times cosine theta minus cosine of 3 theta. We'll take the derivative on both sides with respect to theta. So we have dx over d theta equals to 3 times derivative with respect to theta of cosine theta minus derivative with respect to theta of cosine 3 theta. This will be equals to 3 times the derivative of the cosine function is negative sine theta minus derivative of cosine 3 theta will be negative sine 3 theta. But since we have 3 theta here instead of theta, we'll use the chain rule and multiply it to derivative with respect to theta of 3 theta. So this is going to give us negative 3 sine theta, positive sine 3 theta, and the derivative of 3 theta will be simply 3. So we can take 3 as the common factor and we'll multiply it to sine 3 theta minus sine theta. Right. Now, we will use a trig identity, which is the expansion of sine 3 theta. So the expansion of sine 3 theta is 3 sine theta minus 4 sine cubed theta. Right. So that means we'll replace the sine 3 theta value, 3 sine theta minus 4 sine cubed theta, and this is going to give us the value derivative of x with respect to theta that will be equals to 3 times. So in place of sine 3 theta, we have 3 sine theta minus 4 sine cubed theta minus sine theta. Fine. Now we have 3 sine theta minus sine theta, so that will be equals to 2 times sine theta minus 4 sine cubed theta. Now if we take 2 sine theta as the common factor, so we will have 6 times sine theta. This will get multiplied to 1 minus 2 times sine squared theta. Right. Now this 1 minus 2 sine squared theta is an identity. This is a trig identity, which is simply cosine of 2 theta. So that means we have obtained derivative of x with respect to theta. Its value is 6 times sine theta multiplied to cosine of 2 theta. We are going to label this as equation number 1. Now let's go to the second equation for y. So y is given by 3 sine theta minus sine 3 theta. So we'll take derivative on both sides with respect to theta. So this will be equals to 3 times derivative with respect to theta of sine theta minus derivative with respect to theta of sine 3 theta. Now this gives us 3 times derivative of the sine function is cosine theta minus derivative of sine 3 theta will be 3 times cosine of 3 theta. So we can take 3 as the common factor. So this will get multiplied to cosine theta minus cosine of 3 theta. So we can use the expansion of cosine 3 theta. The cosine 3 theta, that's given by 4 times cosine cubed theta minus 3 times cosine theta. So we'll substitute this value. This will give us derivative of y with respect to theta will be equals to 3 multiplied to cosine theta minus, so here we have to take minus of cosine of 3 theta, which will be simply equals to 4 times cosine cubed theta, this is theta not x, plus 3 times cosine of theta. Right. So we can add 3 times cosine of theta with cosine theta to get 4 times cosine of theta minus 4 cosine cubed theta. Now what we can do, we can take 4 times cosine theta as the common factor. So this will become 12 times cosine theta, which will get multiplied to 1 minus cosine squared theta. Now this is an identity with the value sine squared theta. So we have sine squared theta. So this will be derivative of y with respect to theta, and we're going to label this as equation number 2. Now our task will be to obtain the value of derivative of y with respect to x. For this, all we have to do is Take derivative of y with respect to theta and divide it with derivative of x with respect to theta. So we have obtained derivative of y with respect to theta, so that's 12 times cosine of theta multiplied to sine squared theta. Whole thing is now divided by 6 times sine theta multiplied to cosine of 2 theta. So we have 6 times 2, so that's 12. We have 1 sine theta from the denominator and 1 from the numerator, cancelling out. This leaves us with 2 times cosine theta times sine theta in the numerator, and in the denominator we have cosine of 2 theta. Now 2 times cosine theta times sine theta, that is actually the expansion of sine 2 theta, which is 2 times sine theta times cosine theta. We can replace the numerator with sine of 2 theta. So we have sine 2 theta divided by cosine 2 theta. And this ratio sine of a cosine, that is the tangent function. So we have tangent of 2 theta. So hence we have obtained that derivative of y with respect to x is given in its parametric form, and its value is tangent of 2 theta.